Well, it's surprising.
3000 BC. 3000 BC.
Back to 2000 BC again, but that's a long time ago. They actually knew how to factor. A long time ago. And it's our old buddies from the Middle East.
Egyptian.
Not those. I mean, the Babylonians again. Smart people. Very advanced people. All right. And matter of fact, you can see a little stone carving. It's a little faded, of course, because it's kind of old, but there's a stone carving on there from the Babylonians. All right.
Weird.
Well, it's partly printed, but even the stone carving was not that clear. So, all right, next one, the quadratic formula, which you can see in the top right corner. That's that old formula that you learned a long time ago, right? The quadratic formula was discovered to solve equations such as x squared plus 11x plus 2, which does not factor, right? So you have to use quadratic formula. That was discovered roughly in 628 AD. Long time ago. One who discovered the quadratic formula. Probably won't guess.
Good dude playing marbles.
He is in the top 20, but he's probably the only one in the top 20 that you've never heard of in any fashion whatsoever.
July 1.
His name is Brahma Gupta.
I was gonna guess
I-
that was the next one.
Well, you usually don't hear about this guy until you get, through college, and even then you don't hear of him. But he's number 18 all time. Brahmagupta from India. And there are a lot of great mathematicians from India, quite a few actually. Even currently. I mean, this is like way back when, but even now, pretty much if you look at all the countries in the world, I'd say Russia, India, and America probably produce the most mathematicians right there. Those are the top three. So. Very talented. So, Brahmagupta, he was actually the first one to use the number 0 and negative numbers because nobody else believed those were real numbers and were useful at all. Okay? Changed everything. Matter of fact, this guy also was the first one to figure out that the moon is closer than the sun. Because everybody else thought that the sun was closer than the moon. A little bigger. But, hey, listen, who knew back then? We didn't know anything back then. This guy did, though. Okay, so that's him. Now, natural logarithms discovered. We discussed that in the first semester. 1668. The Bernoullis did some stuff with natural logs. But they weren't the first one to discover that there was a natural log out there. It was another guy. We mentioned him one time way back on test 3. And that was Mercator. Mercator. He's not right, but he did a lot of good stuff. Okay? And that is 1668. All right? Now, absolute value bars. That's also part of the problem we just discussed. Okay, we're doing all the little pieces of the problem here. Who was the first one to use absolute value bars? Well, that happened in 1841. And you may be writing a paper on him because he's in the top 10. Number, hey, who knows their stuff? Number 8, Mr. Weierstrass.
Yeah, I can guess that.
Who is German.
Yes, sure.
Okay? We say Weierstrass in German, they say Weierstrass. All right? And so that was him. Came up with absolute value bars and a whole bunch of good stuff, actually. All right? Now, the formula discovered that generates all trinomials
I don't know who this is.
such that both the plus b and the minus b cases can be solved with no quadratic formula and factor.
Deep way.
That would be July 29th.
At what time?
I don't know if that. 2011.
Wow.
Hey, modern history right here. Guess what? That just happened.
Deep way.
All right? And that is a mathematician known as Wade. The two-hit wonder.
Question.
Right? I got 2 hits. I'll take it. I didn't get 200 formulas like my dad, but hey, 2's not bad. All right? For the good old USA again. So, basically, here's what we have.
Who's the smartest mathematician still living?
Still living? Probably some guy named Peter Lax. Peter Lax is one sharp guy.
Two Americans?
Yeah. He was born in the Czech Republic, actually.
Oh.
But he lives in America now. Smart guy. What type of shoes was he?
What types of shoes one time?
I was like 3 years old. My dad knows all these guys. All the big shots. Okay. I don't remember what he said.
Oh yeah, that guy, he tied my shoes right
He
there.
says I bet like the whole top 10 that are living, but I don't remember. Anyways, there's all old guys to me. So, anyways. That's it. I mean, they're all nice guys to me. Anyways, these are called Wade trinomials.
Where are they?
Wait, where's this right?
Okay, you can just put this at the bottom. So basically a Wade trinomial is if you do any of these four cases, if you do the plus plus, if you do the plus minus, if you do the minus plus, or the minus minus, all those cases are factorable, every one of them. No quadratic formula. Okay? So no matter what combination you use, which is very nice.
Wait, what are the combinations on there?
Okay? Well, we're going to see those on the back page. All right? But basically, if you change that to an 11, you have to use quadratic formula. If you made that,
God bless.
heavens. If you made that a 10 and a 23, it's not going to work anymore, okay? Very rare trinomials you can factor no matter how you change the signs. Okay, so, and then at the bottom is just for fun, but at the very bottom, we have a doctorate, and anytime you get a PhD in a subject, you have to have a professor who has a PhD to say you are good enough to get a PhD. You have done what you were supposed to do to get this degree. You can't just give it to yourself. So, my dad actually got his PhD from this guy named Dr. Shapiro out in California. He got his PhD from this Dr. Zygmunt guy, and then he got his PhD from the previous guy, and you go back, and eventually you hit the number 21 mathematician, and then eventually you hit Weierstrass, who's number 8.
So basically, your dad got his PhD from Weierstrass.
Kind of, in a roundabout way. But it's kind of cool that it actually links all the way back to him. When he told me that as a kid, I was like, who's Weierstrass? I don't know who that is. Now I realize how great he was. That's pretty big deal. So they all link together. Pretty neat. All right, so on the back page, let's do the pattern. And then at the bottom, I'll show you how we'll present it on the test. Okay, this is what you have to do on the test. You'll do a kind of an easy version. But here's what we have to do. Okay, so what happened was we had that old natural log test, test 3, I think it was, right? And you may recall there was a problem kind of like this on the test. Okay, except for I set it up like we did on the front page in A. I set it up like that. But then, okay, so I use this for your notes or for the homework or something, but then I have to have one for the sample and one for the actual test that doesn't use calculator, that doesn't use quadratic formula. So I'm like, how do I make up another one? Okay, I'm sure there are lots of these. I'll just try some numbers. Nothing works. Try some more numbers. Nothing works. And then finally, by total luck, I figured out that if you use 17x and 60, they'll factor both ways, basically. Okay? Doesn't matter if you use plus or minus. All right, so that one works. Then, after a whole lot of searching, I finally found this one. But there's got to be a pattern instead of just doing random guess and check and trying to come up with these that work. I need a pattern so I can just crank out a whole bunch of things, all right? And especially, obviously I don't want to give you one of these on the test that has like 37 and 210. Who wants to do that on the test, right?
Oh, that one, Derek Christie, about 7, 11.
All right, there is a little bit of a pattern here, actually. Then you got 50x and 336. There have to be some other smaller ones between these. I don't want to use that on the test. It's too big, right? I need some nice small examples that will work in that problem on the front page, basically. And so if you look at this, let's do the V column first. There is a little bit of a pattern. If you go from 10 to 17, what's that?
7.
Okay, plus 7, so just put this in the V column. If you go from 17 to 26, that is
Plus 9.
plus 9. And then this one is plus 11 and
Plus 13.
okay. So then using that column right there, you can do the following formula. Every Beecher is the previous Beecher plus 2 and plus 3. Okay? And that works for those. One problem. In this